This is a recording of the webinar on topographical analysis in ArcGIS Pro using raster functions given by Jarlath O'Neil-Dunne on December 18, 2018. Funding for this webinar was provided by AmericaView and was developed in collaboration with VCGI and the University of Vermont Spatial Analysis Lab.
Okay, welcome everyone. So this webinar, what I'm going to focus on are some tips and tricks in working with tile LiDAR topographic data sets within ArcGIS Pro. And starting off here, we're going to move over to the Vermont GeoData portal. And a lot of you have downloaded data from the GeoData portal, probably know that it comes in tiled formats, right? And you may download those tiles individually, or you may go to the entire web folder and download your group, or maybe this group of DEMs arrive to you on a hard drive. And quite often when we're working with LiDAR data, because the tiles are geographically relatively small, we need to mosaic them and perform topographic analyses across a collection of these tiles. And typically the process was to run the mosaic tool, and we'd have to do that overnight because it's going to take a while because the data is such high resolution. And then we're going to go and we're going to run a geoprocessing tool like a hillshade or a slope, and we'll do that overnight. And really, sometimes it can honestly be days before we have our raster products. And what I hope to do today is show you how you can accomplish somewhat similar workflows within ArcGIS Pro, honestly within a matter of minutes. So let's take a look at this existing approach here. So what I've got here is you can see that I've got a couple dozen separate DEMs here, right? They're all individual raster data sets that I've downloaded from VCGI. Now I've created a group layer within ArcGIS, but really, if you think about working with these, right, the display doesn't look very good because they all have different statistics, meaning that the symbology is slightly different. If I want to run topographic analyses, I'd have to do it either on each tile or mosaic those tiles, and then I've got edge effects. So it'd be really nice if I could just have a single mosaic. Now, of course, we know we can run the mosaic within the geoprocessing tools, right? We can just head over here to geoprocessing and run the tool, which is mosaic to new raster, right? And what mosaic to new raster does is it takes a collection of raster data sets, typically tiles, and it'll turn them into a single raster data set. The challenge, like I mentioned, is this can take a rather long time, especially if we have a large collection of rasters. So what I'm going to do here is I'm going to show you a workflow where we create what I call a virtual mosaic. In ArcGIS terminology, this is called a mosaic data set, but allows us to still have each and every one of these raster files here as a separate individual raster data set managed on our file server, but then treat them like a single mosaic. And to do that, I'm going to go into our catalog here. I'm going to right-click on a geodatabase. So important things here, you should have a geodatabase first. If you're not familiar with ArcGIS Pro, it's got this new project format where it creates a geodatabase automatically, but your geodatabase can be anywhere. And then within your geodatabase, you're going to go to New, and you're going to go to Mosaic Dataset, okay? So Mosaic Dataset is just an empty shell there. There's no data populated with it originally, and you should use a different mosaic data set for different data types. So for example, you don't want to use the same mosaic data set for, say, the Vermont ortho photos as you do the digital elevation models. So I'm going to call this mosaic data set DEM. Few important things that you should pay attention to. One is setting the coordinate system. I'm going to use that from my current map. In ArcGIS Pro terminology, this thing here is my map. My map automatically adopts the coordinate system of the first data set that I load. So in this case, it was these DEM tiles, and you can see they're in the NSRS 2007 variant of Vermont State Plane, NAT 83 meters. Okay, under product definition here, we don't need to worry about setting this. This is only useful if you're working with special types of imagery. There's a lot of neat things you can do with mosaic data sets, and we're just going to scratch the surface here. Product properties, don't have to worry about that either. That is for remotely sensed data, but pixel properties, I do want to pay attention here. And so it's a good idea for me to go into the properties of my DEMs and expand the raster information here and pay attention to things like the number of bands. We'd expect a DEM only to have a single raster layer, right? It's not multispectral imagery. We do want to pay attention to the pixel type and pixel depth, which in this case, 32-bit floating point. So I'm going to enter the number of bands here as 1, specify the pixel type as 32-bit floating point. I'm going to click Run. So this is a geoprocessing operation. It generates this mosaic data set. Once again, this mosaic data set is simply a shell that is now sitting there waiting to be populated. So there's nothing in this mosaic data set. I'm going to load it on top of my group tiles there, turn the tiles off so you see there's nothing here, right? There's just emptiness aside from my base map data set. So now it's time to load in the data, if you will. So I'm going to right click and I'm going to go to Add Rasters. And so this allows me to specify the rasters that I want to add to my mosaic data set, okay? So I'm going to add my rasters here. I don't need to worry about the raster type or processing template. That's once again mainly used for certain types of imagery. And from the input data type, I'm going to choose folder here because in my particular case, I have all these separate DEM tiles in an individual folder. I'm going to go then and I'm going to navigate to that folder. So I've got them all stored in this folder DEM tiles. And so what it's going to do now is it's going to scrape that directory looking for any tiles. There are some other options here to pay attention to. I've never played around with these advanced input data options. Under raster processing here, I do recommend doing calculate statistics. You may also want to build pyramids. This will slow things down, but for display purposes, calculate statistics is important. I'm going to not check that right now and just show you why that's important. We're going to run that after the fact. Then we also have some mosaic post-processing. We're not going to touch any of these right now, but we are going to run some of those options later. So I'm going to click Run here, and what it's doing is it is virtually stitching these individual DEMs together into a single raster data set. It's not generating a new raster, so there's not a new GeoTIFF file or Imagine file. So one of the downsides of a mosaic data set is if you're working in other geospatial software packages, right, or want to share this with someone else, it is somewhat limiting. But if you look here right away, you know, what I've got here is as I zoom in a little bit, not only do you see the footprints, the outlines, and let's zoom back out here, the boundary of all those rasters. So that's handy just for coverage. But when you zoom in here, you can see I actually have the raster data set. Now, the reason why it's displaying as gray and not like the nice stretched out DEM is because we didn't compute statistics when we created the raster data set. We know that for rasters, statistics are crucial to displaying them. So that's a pretty easy fix in the the mosaic data set here. I can go over and I can do right click and choose Enhance here and choose Calculate Statistics. And this is just a geoprocessing tool here. Just like you calculate statistics on a raster data set normally, it's going to do that. Once it has those statistics, it knows the min, max, mean, standard deviation, and so forth. That's what we need in order to do symbology within ArcGIS. So same stuff as we've always done, only we're running this on a mosaic data set with a collection of rasters. While we're running this, I'll just mention that because I've muted all of you, if you do have questions or something's not clear, please type them into the chat window and I'll take a look. Okay, so now that we've completed this, we can see that I have this seamless collection of data. And this is super handy because maybe I want to go in and I want to adjust my symbology here. So let's say I'd like to apply a nice, more sort of topographic color ramp here. What you're going to notice is that color ramp is applied seamlessly across all the rasters in my mosaic data set. So once again, although I have this collection of over a dozen raster tiles, they're treated seamlessly with respect to symbology. They're treated like it is a single mosaic. So now I'm going to turn off the footprint and the boundary just to show you how clear this is. Now this is nice in itself, right? We've got a single raster data set here that we're working with and we can apply symbology. But let's take a look at what if we want to do some enhancements to this raster. So something that we'd often like to do for symbology purposes and cartographic enhancement is to compute a hillshade. Running the hillshade geoprocessing tool on a raster of this size, probably going to take maybe a couple hours. And if it's a really large one, could be something that we have to run for a day or so. So I'm going to go to the Analysis tab here in ArcGIS Pro, and I'm going to click on this thing called Raster Functions. So Raster Functions, I like to think of them as virtual processing. What they do is they create, if you will, renditions of your data. They're not actually generating new data. They're creating renditions of it sort of almost in memory. And raster functions are limited. You don't have the full suite of raster geoprocessing tools, but you do have some. So we're gonna run a hillshade here on a raster mosaic data set that has millions and millions of pixels, right? Very, very large data set. So I'm going to choose my mosaic data set here, which is this DEM. Okay, I'm going to accept the defaults, and I'm going to click this button here for Create New Layer. And it does just that. It creates a new layer. So now you can see I've got a hillshade for this entire mosaic data set that was generated in a number of seconds. Those of you that have been running traditional geoprocessing tools, right, we would have had to gone away, pause this webinar, and come back later this evening. Now, if we go into the properties of this hillshade here, we're going to notice under the source location here that it's not actually pointing to a new raster, right? There's no TIFF or .img extension there. You can see that it's pointing to my DEM, which is my mosaic data set, and that its location is in this temp directory. That's not where my ArcGIS Pro is stored. This is where it stores this virtual representation of the DEM. Okay, so this is entirely virtual. And these raster functions are super handy, right? So we can go down here and just take a look at all the functions we have available to us. For example, you can fill sinks and do flow accumulation. So if you need to do some hydrologic modeling, this stuff will execute in tens of seconds as opposed to hours. Let's go down and take a look at some more surface operations. I'm going to run aspect slope on this. So this is a tool that's fairly new in ArcGIS Pro that combines both the aspect and the slope operations. I'm going to run that on that DEM mosaic. Once again, I'll create new layer, and you can see here that executes within a matter of seconds. And now I've got this really nice aspect slope layer. Going into the properties, once again, we see that it points to this temporary raster representation that is stored on my local hard drive. Okay, so that is just sitting there. Maybe I want to go in and compute something like curvature, right? I want a curvature raster. Once again, that's available in the functions. Simply select my mosaic data set, click Create New Layer, and bam, I've produced a curvature raster for this entire area. And we can zoom in there and we can pan around, and you can see that as I pan, it treats each and every one of those tiles as part of a seamless raster mosaic data set. So super handy. So one of the questions you're probably having right now is, you know, what if I want to get this into another software package, right? Or if I want to share it with a friend? Well, at any time you create a data set, you can right click, choose data, and you can go to export raster. And now we can actually export this to a new raster. I'm not going to do this because this can take minutes, if not hours in some cases, because it's going to actually write out to a new data file there. All right, just some other tips here on working with mosaic data sets really quickly. You'll probably notice that here, sometimes as you zoom out really far, the rasters disappear, okay, and it just shows the extent or the tile boundaries, all right, and then as I zoom into a certain scale, it eventually shows up. If you'd like to see this at all scales, the best way I've found to do that is to right-click on your mosaic data set, go to Optimize, and then click on this thing called Build Overviews here. Okay, and I'm just going to accept the defaults and build overviews. And ideally, once this build overviews process is done, I'll be able to see the actual data at any scale I'm zoomed out to. Okay, so building overviews sometimes can take a little bit longer than the other raster functions that we've been executing that run in a matter of seconds, but still, like I said, useful, especially if you're doing some sort of cartographic display operations and you really want to not just see the outlines or the boundary at a zoomed out scale, but you want to see everyone. Okay, so now we can see here that our DEM shows up when we're zoomed out and when we're zoomed in. Okay, the annoying thing about overviews is it resets the symbology. Okay, so hopefully that gives you an idea of how to use raster data sets. I'll just finish up with another little demo here. These raster functions are also super handy if you have some large traditional mosaics. So in this case, we're in the midst of mapping land cover for the state of Vermont here. I've got a DEM and a DSM. These cover parts of Addison. Okay, if we right-click and go to the properties here, and oops, says the source information is unavailable. Oh. Maybe that's not a good sign. You'll have to just take my word that these are very large raster data sets, multiple gigabytes. But once again, I can use raster functions here. And I have a DSM, which represents the true 3D surface, right? That's everything, buildings and trees, elevations, relative to sea level or however they were computed. And then I've got the DEM, which represents the bare earth topographic surface. If I'd like to measure the height of features above ground, I'd like to generate what we call an NDSM, or normalized digital surface model, height above ground. If I were to subtract these two rasters using the raster calculator, that would take a really long time when I'm working with data sets that have millions and millions of pixels associated with them. So I'm going to go in here and use the raster function, and I'm going to select my the minus raster function, and I'm taking the DEM and subtracting it from the DSM. I'm going to click on Create New Layer here, and then what we see pretty quickly is this brand new, okay, normalized digital surface model, which as we zoom in here and it refreshes, right, we're going to see things like the buildings and all of that. So if we take a look at this and then turn on the base imagery there, you can see how that turns out. Once again, if we want to do any type of cartographic enhancement here, going in and doing something like hillshade, assuming one can spell hillshade, or maybe we want to do a shaded relief here, we can take that new raster function. So this is a temporary raster. Now we're going to take create a temporary raster on top of a temporary raster, this shaded relief, to improve the cartographic appearance of it. And bam, we can see that, right? So we're doing things in a matter of seconds that would have taken us hours. And I'll just wrap up by saying raster functions aren't going to solve all of your problems out there, but right now, if you're going through and you're downloading tiles of raster data, and then you're mosaic them, and then you're running a hillshade geoprocessing operation, and then you're running a slope operation, not only are these things really slow, but you're creating a lot of data derivatives which are requiring storage. And maybe storage is free or cheap for you, but I think a lot of us nowadays are dealing with, especially when it comes to LiDAR data, some substantial data management issues. And so the beauty of raster functions is because they're not writing out new rasters, these virtual layers allow us to work with large topographic raster data sets quickly and more efficiently.